Hello everyone, welcome to the 10th tutorial session of Probability Foundation for Electrical Engineers, whose instructor is Professor Krishna Jagannathan from IIT Madras, and I am Satyavikram Pratap Singh, APMRF Research Scholar at IIT Bombay. So today we will see the few of the numerical problems which will help you to solve the current assignment. Okay, moving forward, this is the first problem before you. Try to solve this and let me know if you face any problem. Okay, let me give the solution for this. The problem is saying that if for an integrable random variable x, which identify the tail sum formula for the ex. Okay, so by the definition also you can see that the option E is actually matching. But let option B is matching. But let's move see that. So what is actually the tail sum formula? It is actually for an integral random variable x, that is ex less than infinity. Okay, the tail sum identity expresses that ex using this tail property survival function, that is expectation of x is equal to 0 to infinity probability of x greater than x dx minus 0 to infinity probability of x less than minus x of dx. Okay, so the option B is actually correct. So when you see that if x is greater than equal to 0, as the second integral is 0 and it reduces to expectation of x is equal to, because it will become 0, then it will be simply this. Okay, probability of x greater than x dx. Okay, and consistency checks you can also do that. Non-negative x is nearly equal to exponential of z. Exponential of x is equal to 0 to infinity e power minus lambda x dx is equal to 1 upon lambda. So by symmetry wise, you can see that expectation of x is equal to 0. The two integrals cancel. Okay. Then also why the other option not the tail sum formula? When you see the first option, this is usually a density formula that minus infinity to infinity x of fx dx. Okay, and also when you see the option C, that is also equal to the it is not expectation of, but this equal to tail formula for the split value, not the complete. Okay, and when you see the last option, it's also it is very general. So a valid discrete tail sum for the non-negative integral values x is expectation of x k is equal to 1 to infinity probability of x greater than, but as written it's neither general nor correctly scoped. Okay, that's why the option B is actually correct. Try to solve this problem. Okay, let me see that problem. So here it is saying that for a discrete non-negative x with PMF is equal to probability x equal to x, which is correct. Okay, so the options is given as expectation of x is equal to when the summation is from k is greater than equal to 0, k pk is equal to summation of n greater equal to 0 probability of x greater than n, or you can say that here also the k option is not there and k square is there and probability of x greater than equal to n of whole square. Okay, let's see that. So by the tail sum identity, that non-negative integer x. So if you take the x values from 0 to 1, 2, 3, 4, and dot dot dot, and expectation of x is less than infinity, then expectation of x is equal to n is equal to 0 to infinity probability of x greater than n. Okay, is equal to n from n to infinity, that is probability x greater equal to n. Okay, so this is exactly the option A state that k greater than 0 and k multiplied by pk. Okay, why it's true, that let's check it out. When you say that k is equal to n is equal to 1 to infinity 1, n is equal to 1 to infinity, or n is less than equal to k, when that apply to the x. Okay, when you apply this same thing with the x, so then swap the sum with the expectation by the Tonelli principle. So expectation of 1 is equal probability of x greater than equal to n, or you can say that n is equal to infinity probability of x greater than n. Okay, so this evidence to k pk, that is equal to n is equal to 0 to infinity and plus k is equal to n plus 1 to infinity pk, and k is equal to 0 to infinity pk and n is equal to 0 to k minus 1 1. Okay, expectation of x. So by the quick checks, say the Bernoulli's x belonging to 0 to 1. So this is p is equal to expectation of x. They're similar with the geometric option also. Okay. Let's move forward. Try to solve the other problem. Try to solve this. So let me give the solution for this. If x is a uniform over 2 to the power a, 2 to the power a plus 1 and 2 to the power b, all equally likely. Okay. All equally likely. So how many points are there in the support? When you see a is equal to b minus a or b minus a plus 1 or 2 to the power b minus 2 to the power a or d is 2 to the power b minus a. Okay. So when you say that this is a set of consecutive integers, that is 2 to 2a 2a plus 1 dot 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 and 2b. Okay. From consecutive integer from m to n inclusive, the count is n minus m plus 1. Okay. So here the m is equal to 2a and n is equal to 2b. So the point will be equal to 2b minus 2a plus 1. Okay. And is equal to 2 to the 2b minus a plus 1, and b minus a is a missing a factor 2 and the sum and the plus 1. Okay, so b minus a plus 1 is a missing the factor 2 and 2b minus 2a is missing the plus 1. Okay, so that's why this all the options are actually not correct. But when you say that 2b minus a in correct expression is there, so correct option is 2b minus a plus 1. So that is all the options are actually wrong. Okay, try to solve this problem. Okay. Absolutely take the headphone. Yeah. So when you see that for the same x which is given in the question number 3, that is this one, that x is a uniform distribution over the 2 to the power a to the power a plus 1 dot 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 2 to the power b. So it is asking that what is the expectation of x basically. Okay. So when you see that, see the identity of the distribution, axis distribution 2a, 2a plus 1 and 2b. So number of points is 2b minus a plus 1 and each has the probability 1 upon 2b minus a plus 1. So expectation of a discrete uniform, when you see it's for any arithmetic sequence m plus 1 dot 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 n inclusive. So expectation of the uniform m dot 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 n is equal to m plus n by 2. So here the m is equal to 2a and n is equal to 2b. So expectation of x is 2a plus 2b by 2. So it will come out to be a plus b. Okay. So it is matching with the option B, where you can see that 1 upon b minus a plus 1, 1 upon b minus a plus 1, k is equal to a plus b 2k, and which is equal to 1 upon b minus a plus 1 dot 2, and that is 2 summation of k is equal to a plus b, or k is equal to 2 divided by b minus a plus 1 dot b minus a plus 1 a plus b by 2 is equal to a plus b. So b matches the correct value. Okay. Why the other or others are wrong? So to say 2 to the power 2k or squared. Okay, so this is not a not our support, so this is a very wrong. So missing the averaging factor, it's just a sum, not an expectation. So option C is not correct. So option D is 2b minus 2a, b minus a is equal to a constant independent of a b, that is incorrect. Okay. So the option B is actually matching. So option B is actually correct. So moving forward to see the question number 5. Try to solve it. Okay, let me give the solution for this. When you see the question 5, it is saying that let y is equal to ax plus b and with a as greater than 0. So it is asking what is the correlation between x comma y. Okay, equal to. When you see here, so how to proceed with this? Okay, when you see y is equal to a x plus b, correlation is basically rho xy is equal to covariance of xy divided by sigma x comma dot sigma y, where sigma x is the under root of variance of x and sigma y is equal to under root of variance of y. Okay, so the when you're plugging the y is equal to ax plus b with a is greater than 0, so covariance is basically the linear in each argument and constant dropout. Okay, so that's why when you take it, so will come out a will come out a will come out, so it will become covariance of xx plus covariance of x comma b plus is equal to a times of variance of x. Okay, so variance of y is equal to variance of ax plus b is equal to a times of variance of x, that is so it will become variance of a square times of variance of x, that is implies that sigma y is equal to a times of sigma x, so it will become a times of sigma x. So rho xy is equal to a times of variance x divided by sigma x in the bracket a times of sigma x, so a times of sigma x square divided by a times of sigma x square, which is equal to 1. Okay, so that's option D is actually correct. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. When you see that, what is saying that theta is a uniform distribution in 0 to 2 pi. Okay, and x is equal to cos theta and y is equal to sin theta. Which are the options are actually, which statement is actually true? When you say x, y's are independent and uncorrelated, only uncorrelated or independent, basically you have to tell the whether it is correlated or actually independent basically. With theta is nearly equal to uniform distribution in 0 to 2 pi, set x is equal to cos theta and y is equal to sin theta. Find out the expectation of x. When you find it out, is equal to 1 upon 2 pi 0 to 2 pi cos theta d theta is equal to, it will come out to be 0, and same with the expectation of y also, 1 upon 2 pi 0 to 2 pi sin theta d theta is equal to 0. Okay, so what is the value of expectation of xy? This is equal to 1 upon 2 pi 0 to 2 pi cos theta sin theta d theta. This also will come out to be 0. So when you find out the covariance of xy, that is expectation of xy minus expectation of x and multiplied by expectation of y, that is 0 minus 0 is equal to 0. Okay, so x and y are uncorrelated basically. So dependence are, so they are not independent basically. Okay, so they are uncorrelated, and dependency also you can see that x square plus y square that is equal to 1. So this is strict first for constant. So when you x means y, so it will equal to plus minus root 1 minus x square. The sign depends upon x. A pair we support with the one-dimensional curve in R square cannot have a product. So they are not independent basically. Okay. So the correct option when you see from the figure also, that it will come out to be that it is uncorrelated. Uncorrelated is there, and they are not independent. They are not independent. Okay. So the option B is correct. Okay. Let's move forward. Try to solve this problem. Okay, when you see this problem, it is saying with the same x and y, which is given in the question number 6. When you see theta is nearly equal to uniform distribution in 0 to 2 pi, x is equal to cos theta and y is equal to sine theta. Okay, When you see here, so it is asking which is the option are actually correct, that expectation of xy is equal to 0, expectation of x square y square is equal to 1 by 4, both a and b, or neither of a and b. Okay, let's try to solve this. Let's try to solve this. When you see, uh, uh, let's find out first the expectation of xy. Expectation of xy is will be equal to 1 upon 2 pi 0 to 2 pi cos theta sin theta d theta. It will be equal to 1 upon 4 pi, because when you see the cos theta sin theta, it will be converted to the 2 sin theta by multiplying 2 and divided by 2. Okay, so it will be equal to 1 upon 4 pi 0 to 2 pi sin 2 theta d theta. When you find it out, it will come out to be 0. And also when you say the expectation of x square y square, it is simply cos square theta. So when you find it out, it will come up to 1 by 4 1 minus cos 4 theta. So it will be 1 by 8 1 minus cos 4 theta. So try to solve this. It will be 1 upon 2 pi 0 to 2 pi 1 by 8 1 minus cos 4 theta d theta. Multiply it. When you find it out this, it will come out to be 1 by 8. Okay, so the option, when you see, the option 1 is actually correct, not b, because it is coming out to be 1 by 8. Okay, so neither a nor b both there, so option a is actually correct. Okay, that is similar problem, that when you find it out the expectation of xy, this is simply you have to, what you have to do, just multiply the terms. X is cos theta, y is sin theta, just multiply, it will become 1 upon 2 pi 0 to 2 pi cos theta sin theta, just multiply and divide by 2. It will be equal to 1 upon 4 pi 0 to 2 pi sin 2 theta d theta. It will come out to be 0. When you find it out expectation of x square y square, it is simply equal to cos square theta sin square theta, multiply 4 and divide by 4. It will be 1 by 4 sin square 2 theta. Sin square, when you see cos 4 theta, what is the value of cos 4 theta? It will be equal to 1 minus 2 sin square 2 theta. 2 sin square 2 theta, sin square 2 theta will be equal to 1 minus cos 4 theta by 2. 1 by 8 1 minus cos 4 theta. Simply 1 upon 2 pi 0 to 2 pi 1 by 8 1 minus cos 4 theta d theta equal to 1 by 8 dot 1 upon 2 pi theta minus 1 by 4 sin 2 theta 4 theta, it is 0 to 2 pi, it equal to 1 upon 8. Okay, try to solve this problem. Okay, let me give you the solution for this. When in the question, it is asking a travel time is a mixture. That is a car with a 3 hour. It is actually having WP is P and bus which is 5H. That is WP is 1 by P. So it is asking what is expectation time. Okay, basically. So when you see the model, the mixture with an indicator, let's assume that it is identity is actually equal to one, which is a car, and it is following the Bernoulli's equation, that is P. Okay. So when you see that travel time is three here from the question itself of 3 hours. Three if I is equal to one, where the car is there, and I is equal to zero, that is bus is there. Okay. So the total time when you see multiplied time is equal to 3I plus 5 times of 1 minus I. Okay, when you take the expectation of x, expectation is 3I plus 5 I 1 minus I. That is 3 times the expectation of I plus 5. 1 minus expectation of I is equal to 3p plus 5 times of 1 minus p. That is 5 minus 3p plus 5 minus 5p. That is 5 minus 2p. Okay. So the correct option when you see 3p, uh, 3 1 minus p, 3p 5 1 minus p, 3p. So correct option is A. Okay, here only thing is that you have to derive the equation in such a manner that it will follow the p and 1 minus p criteria basically. So here also you can see the 1 minus 1 is 0, so that is simply the 3I plus 5 1 minus I, so it will be equal to 3p plus 5 1 minus p. Okay, try to solve this problem. Okay, let me give the solution for this. So here in the question it's asking if z is equal to summation of I is equal to 1 to z I square with ji is equal to normal distribution 0 to 1. Then z has a gamma which is k is equal to n by 2 and theta is equal to 2, or chi square n with mean is equal to n and variance is 2n. Exponential in the 1 or normal distribution is n or 2n. Okay. So when you see here, so there's definition by definition that when you see the normal distribution 0 to y, z is simply by definition is I is equal to 1 to n z I square, and by definition of the chi square, z is simply is equal to chi square of n. Okay. When you see the MGM proof, that is simple. That is, I'm not going into that, but gamma square, gamma n of square is in the n is equal to chi square n is equal to gamma of n by 2 comma 2. Okay, this is a derivation which is I have already given. You can see that. And when you find it out, what is the variance for chi square or in the gamma of n by 2 comma n comma 2? So the expectation of z will come out to be n and variance will come out to be 2n. Okay. So that is correct that gamma is equal in the k is equal to n by 2 and theta is equal to n. That is correct. And chi square n with mean, that is also correct. But when you see the exponential, that is not true in the general. But and also it is not correct with the normal distribution. So conclusion is basically the z is nearly equal to chi square of n, and it is a gamma function n by 2 comma 2. Okay. So the correct option is gamma n by 2 and 2. Option A is actually correct. And you see, and when you see the option B, chi square in win, that is also correct. This is not correct. Okay. Let's move forward. Try to solve this problem. Okay, let me give the solution for this. It is asking that if for n is equal to 50 in the question number 9, what is the variance of z? Okay, when you see that we have already derived that z is the chi square in n, which is gamma value is n by 2 comma 2, basically that k is n by 2 and theta is 2. When you plug the value of n is equal to 50, so variance of z is simply equal to 2n. That is 2 multiplied by 50, that is equal to 100. Okay. Why? Because for chi square n, the expectation of z is equal to n, variance of z is 2n. So equivalently for gamma k theta, variance of z is equal to k theta square. And here k is equal to n by 2 and theta is equal to 2, that is 4. So n by 2 multiplied by 4 is equal to 2n. So that is simply 50. When you keep it at 50, it will come out to be 100. Okay, so the option C is actually correct. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. So here it is saying the MGF, that is m of x of t, the exponential of 2 e to the power t minus 1. It is asking which is corresponding to either a binomial, Poisson geometric, or normal distribution with different values. So when you see that keep Poisson distribution, that is exponential of lambda e to the power t minus 1. And when you see the binomial, it is simply 1 minus p plus p e to the power t to the power m. Geometric progression, that is similar, but it is going to the denominator, that is p 1 minus p to the power e to the power t, e to the power t. When you check it with the monotonicity, that is equal to, or the Poisson distribution, that is expectation of x is equal to lambda of 2, variance of lambda is equal to 2, that is actually matching. And when you differentiate it, it is actually coming the value of 2 at the lambda itself. Okay, and see the first kurtosis and second kurtosis. When you find it out that mx double dash of 0 minus mx dash 0 of whole square, it is also coming to. So when you see the sanity, it is actually matching with the Poisson distribution lambda is equal to 2. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. The MGF, when you see the MYT is equal to 3 by 4 e to the power t plus 1 by 4 to the power 10. Uh, that is binomial distribution. It is asking corresponding to binomial distribution or Poisson distribution or negative binomial or hypergeometry. When you see that binomial mt is equal to 1 minus p plus p e to the power t to the power n, and mt is exponential of lambda e to the power t minus 1. So mt is simply equal to p divided by 1 minus p to the power e to the power t power h. When you see how it is matching with the binomial form, keeping that n is equal to 10 and p is equal to 3 by 4. Okay. When you check the binomial, it is coming 7.5 and 1.875. Okay. So that is simply equal to binomial of 10, and p is equal to 3 by 4. Okay. Try to solve this problem. Okay, let me give the solution. Here, if you see it is saying x is in the Poisson distribution of 2 and y is the binomial distribution 10, 3 by 4 are independent. Okay, then expectation of xy is equal to. When you see the expectation of xy is equal to expectation of x and multiplied by expectation of y, this simply when you find it out expectation of xy such that y is there. So when you plug in the Poisson distribution of 2, that is exponential of x is come out to be 2, and when you fit in the binomial distribution comma 3 by 4, this is expectation is np simply. So np is 10 multiplied by 3 by 4, it is 7.5. Multiply at 2 times of 7.5 is equal to 15 basically. Okay, so the option b is actually correct because it is matching with the expectation of x multiplied by expectation of y. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this problem. It is saying that for independent non-negative integer xy, probability of x plus y is equal to 2 can be computed y. Okay, when you see the option for the independent non-negative integer value of x and y, probability of x plus y is equal to n. So you can separate it out like k is equal to 0 to n, probability of x is equal to k, and probability of y is equal to n minus k. So this is the negative and this is a discrete calculation for these PMFs. So when you keep the value as n is equal to 2, because here in the problem it is saying it is x plus y is equal to 2, so you can say that that probability of x equal to 0 and probability of y is equal to 2. That is 0, 2 minus 2 and 2 basically. So plus probability of x equal to 1 and probability of y is equal to 1 plus probability of x equal to 2 and probability of y is equal to 0. Okay. This message with the option A. There summation of k is greater than or equal to 0 effectively means k is equal to 0, 1, comma 2, because terms with the 2 minus k is less than 0 are 0. Okay. So why the others are wrong? When you see the option B, that is probability of x equal to 0, 2 is equal to 2 and probability of this is matches when the only case 2, 2 or misses 0, 2 and 1, 1. Okay. So that is simply the option option A is actually correct. Okay. So that's all for the today's tutorial session. If you face any doubt, just let me know in the next tutorial session. Thank you so much for joining.